Welcome to a session of geometry. I'm your moderator, Tanushree Banerjee, and together we shall discuss lines, angles, and polygons. Before we get into our session of geometry, let's recollect and discuss some of the basics of shapes and designs. 1. A line segment joins two points. 2. A ray is a line that starts at one point and continues infinitely in a direction. 3. A rectangle is a four-sided polygon. 4. A square is a special rectangle. 5. A rhombus is a special parallelogram. So now that we have covered the basic concepts, we're ready to move into our first geometry lesson. Let's start with lines. Here we see what parallel lines, transversals, and quadrants are. Parallel lines are lines that never intersect. Transversals are lines that cross two different parallel lines. Quadrants aren't particularly lines, but are the four sections into which the coordinate plane is divided by the x-axis and the y-axis. Now let's move on to polygons. A polygon is a closed figure formed by line segments that never cross and which maintain straight sides. Here are some examples of polygons and non-polygons. Now it's question and answer time, folks. On the left, you see some shapes. Can you identify which is a polygon and which is not? The first shape isn't a polygon because it has a curved side. The second shape is a polygon because it is closed by sides and formed by segments. The third shape is not because it is open and its sides do not connect. Now we can discuss regular polygons and irregular polygons. In a regular polygon, all sides and angles are congruent. If a polygon does not follow these conditions, we call it an irregular polygon. Below are examples of regular polygons and irregular polygons. Can you identify the regular polygons and irregular polygons from this chart? The first one is a regular polygon because all its sides and angles are congruent. The second one is an irregular polygon because its sides and angles are not congruent to each other. The third one is a regular polygon because again, all its sides and angles are equal. We are now ready to explore yet two other types of polygons. A convex polygon has no angles pointing inwards. More precisely, no internal angle can be more than 180 degrees. If any internal angle is greater than 180 degrees, then the polygon is concave. Think, concave has a cave in it, else it is convex. The following are some images of concave and convex polygons. Can you tell which one is concave and which one is convex? The first image is that of a convex polygon because its internal angles are less than 180 degrees. The second image is a concave polygon because its sides cave in. The third one is convex because all its internal angles are less than 180 degrees. Now, let us have a look at how polygons can be classified by their angles. Let's start with interior angles. An interior angle is an angle inside a shape. The sum of interior angles of a polygon equals n minus 2 in parentheses times 180 degrees. Each interior angle of a regular polygon equals the sum of interior angles of a polygon divided by n. Remember, in this case, n stands for the number of sides of a polygon. Also to remember, interior angle plus exterior angle equals 180 degrees. Now it's question time. Question: what is the value of each interior angle of an octagon, and what are the sum of all the interior angles? Correct. Each interior angle of an octagon equals 135 degrees. The sum of all the interior angles of an octagon is 1080 degrees. Since we now know about interior angles, let's talk a little about exterior angles. An exterior angle is the angle between any side of a shape and a line extended from the next side. The sum of exterior angles of a polygon equals 360 degrees. Each exterior angle of a regular polygon equals 360 degrees divided by n, in which n stands for the number of sides of a polygon. The exterior angle plus interior angle equals 180 degrees. Now it's again question time. What is the value of each exterior angle of a pentagon, and what are the sum of all the exterior angles? Correct. Each exterior angle of a pentagon is 72 degrees. The sum of all the exterior angles of a pentagon equals 360 degrees. The table below shows us a list of polygons with the values of their single interior angle and the sum of all interior angles. Any n-sided polygon has one interior angle, as with the formula of n minus 2 times 180 degrees divided by n, and the sum of their interior angles as n minus 2 times 180 degrees. Now we are ready to see other forms of angles. There are 4 types of angles: complementary angles, supplementary angles, adjacent, and vertical angles. 2 angles are complementary when they add up to 90 degrees. They are supplementary when they add up to 180 degrees. 2 sides are adjacent if they share a common side and vertex. Vertical angles share a common vertex and are opposite each other. Now that we know the 4 types of angles, we might think of measuring them. Well, how do we measure them? We can use a protractor. Lining up the vertex with the crossed lines and the first ray with the line pointing to 0, we extend the second ray to clearly see where it is pointing. In this example, it is pointing to 138. So this angle measures 138 degrees. Quick tip: sometimes the angle will be smaller than the protractor. Use the straight edge to extend the ray to make it easier to read the measurement. In the example given here, the second ray on this angle points to 45, so this is a 45-degree angle. Angles can also be measured with your angle ruler or estimation skills. For the angle ruler, you use the same rules you would for a protractor. Estimation is a way to find the approximate measure of an angle. You can use the base angles of 90 degrees, 180 degrees, 270 degrees, and 360 degrees to find your estimate measure of an angle. We know how to measure angles now, but why not try forming them? An angle can be formed when a transversal or a straight line cuts through parallel lines. You can note that such angles are vertically opposite angles that are equal. Alternate angles formed are equal. Corresponding angles formed are also equal. The below image is of angles in a diagram with a transversal. Now, moving on to symmetry. There is two types of symmetry: rotational symmetry and reflectional symmetry. Reflectional symmetry is symmetry with respect to reflection, almost like a mirror image of a shape connected to it. Rotational symmetry is a shape that looks the same after a rotation. Now you might wonder what a rotation is. A rotation is the process of circular motion around the center. Now, are we ready to move on to something fun? Now, finally, something fun. Do you know that you can do something creative with what you know about these polygons? You can make a tessellation. A tessellation of a flat surface is the tiling of a plane using one or more geometric shapes called tiles, with no overlaps and no gaps. Hope you have fun creating your own. This slideshow would not have been possible without the help of the following sites: helpingwithmath.com, mathisfun.com, schoolmart.com, educators.com, revestintil.com, goldacademy.org, mind42.com, icoachmath.com, lemonlimeadventures.com, slideshare.net, math.tutorvista.com, and of course the support from my parents and teachers. Thank you for watching. This is Symmetry signing off. I hope you enjoyed the presentation.